I just don't need energy. When you're dealing with gas, you just need to know the total energy, which is BTU basically. You don't care how that gas is being used in every second. But when it comes to electricity, not only do you need to know the total energy, which is kilowatt hour, you need to know the kilowatt as well. Why? It's all because of your billing structure, and I'm going to explain it more.
It's kind of a strange, what they call energy utility index. It has to be power utility index. Because you're measuring the power, it's per unit year.
Because you convert it to year, yeah, it becomes
Because
power.
you're calculating per year.
Yeah,
So it's really a power, right?
Power. It's the energy usage per year.
That would be
power,
So
yes.
that should be power utility.
Yes, yes. But,
That's interesting.
yeah. And then there is a big disconnect between electricity and utility in terms of gas, because if you work with boilers, furnaces, energy usage units that are using gas, everything is in British system. But when it comes to electricity, everything is a silent. And everything is watt, kilowatt, meter, second, temperature is C's, you know, so it's completely two different worlds. So for electricity, one thing that is becoming very important is the demand, and that's why we use the kilowatt. I want to give you a little bit different pictures. A power plant. Let's assume you want to build a power plant, right? You're an investor, you're trying to build a power plant, sell the electricity, and you're trying to build a nuclear power plant. Do you have any idea what's the cost of a nuclear power plant these days to build?
Lots.
Yeah, what's a lot?
Somewhere, I think, known, somewhere in there.
It's about $8 to $10 billion. You know how long does it take to build a power plant that is nuclear power plant? About 10 to 12 years from the first to its finish. So somebody has to come here and spend $12 billion and would not get a dime back about 12 years. Right? It's a huge investment. Somebody has to pay for this investment. Who pays for it? Partially it's paid by the consumers. Partially is paid by the investors, partially paid by the federal government, but the part that is paid by the consumer is the part that I call energy auditing. And that's the part that is going to show up on kilowatt. So when you pay for your electricity bill, it has two parts. It has the consumption part, it has the demand part. Right? If all of us in the afternoon at 6 to 8 or 6 to 9 use the maximum amount of electricity in a residential place, right? So let's assume the residential place electricity usage at the hour of between 6 to 9 is at 100. No unit, I'm just saying 100, right? The rest of the day, it's at 5 or 10, because you're not home. Or if you're home, you don't need electricity, you don't watch TV and all kind of things, right? Now you want to build a power plant. What kind of a power plant do you have to build? You have to build a power plant that is going to supply the 100 units of electricity needed at 8 p.m. Right? Because if you don't build a power plant that's huge, what happens? You're going to have problem, you're going to lose electricity in some area of the residential, and that's not acceptable. Well, here's the problem. You build a power plant, that is you're going to only use 20% of its power, only for 2 hours. The rest of the 22 hours is just going to be working at 30% of operation. Who's going to pay for that differences? That is where the demand comes to place, and that is called kilowatt. That is why when they are measuring your electricity, it is very important for them not only to know how much total energy you use, but what was the peak power you used. And based on the peak power, you get penalized basically. If your peak power is much, much more than your average usage, you pay a hefty penalty because they have to build a bigger power plant to satisfy your demand. Now, when it comes to residential houses, the demand really doesn't play that kind of a role. I'll just leave the residential because we can make a connection to it. The demand really plays an important role in the factories. Actually, if you look at most of your electricity bill for residential, there is no charges for demand. Right? There are charges for when you are using your electricity depending on how smart is your meter. you know, if you're using, for example, electricity during the 8 to 5, or you're using it more on weekend, right? There are smart meter that is being installed. Check your meter when you go home tonight. Look at your meter to see if it's a smart meter or a regular meter. Smart meters are the meters that not only they measure the electricity, but they measure the time of the electricity usage. So depending on how you use it, when you use it, the electricity could be cheaper. Electricity is much cheaper over the weekend because a lot of factories are closed, right? So, one of the other things that is very important to calculate for electricity usage is a load factor. Load factor determines basically of the electrical efficiency of the whole facility. And that means how many kilowatt hours that you have, you multiply by the number of the hours that you basically use that kilowatt hour, you divide it by the peak kilowatt that you had, and you come up with the number. If the number is close by, that means you don't have a lot of peaks. Your energy usage is very, very, uniform. Now, why this is important? Because if your energy usage is very uniform, you don't have many number of the peaks in your facility, you have a negotiating power. You can go to Edison and sit them on a table and tell them, I don't have many peaks, I don't want to get charged this amount of energy for demand, I want to have this rating. Energy is negotiable when it comes to industrial locations. At your home, you don't have that negotiating power. So, to continue that, let's look at the bills that you get. Okay. It's very important when you get a bill, you understand it correctly, you can recognize the charges differently. Gas are simple because you have a cubic feet usage of gas, there's a price for every cubic feet, you multiply it, you know how much is the total. Electricity is a 3-to-1. The demand is separated, the amount of the hours or time during the day that it has been used has to be separated, and you have to understand exactly what are the charges. Why this is important? I'll give you a simple example. For example, your factory buys electricity, and based on the billing rate that you have, when you look at it, you see you have the highest charge in the morning from the hour of 8 to 10. Right? And that's the time that actually the factory starts working. And when I look at my bill, when I drive based on hours, I see I have the most consumption in that 2 hours as well. So if I want to save energy, the very first thing comes to me is how can I shift that maximum energy usage from the hour of 8 to 10, maybe to the afternoon, right? Because my billing is the way set up is going to charge me the maximum amount of money for those 2 hours in the morning. So when I do my energy auditing, I walk around. Most of the time, this is what I find. There is a compressor somewhere, right? Compressor is a big usage of energy. It's one of the big users of energy, it's compressors. Whenever you go to a facility, you see a compressor, it's a nightmare. Because you have to get the air, compress it, a lot of energy, more than 75% of the energy is dissipated by heat, is lost basically, and every facility, depending on the size, they need different compressors. So you have the compressor running. Most of the facilities, what they do is during the morning they come, they have to turn on the compressors, start basically charging air to the units they want so they can start operation. Right? I give you this example. I was auditing a facility, and what I did for them was I calculated basically what's the energy usage for compressor for that 2 hours. What does it cost if I buy a high pressure air reservoir? There's a cost for that, right? And the night before, so what we did was we bought a reservoir, we put it over there, and the night before the shift was over, every night we charged the reservoir. And the reservoir was big enough to provide the high power energy that we needed, high power pressure air that we needed in the morning, right? So you basically start operating your compressors at night when the energy is cheap. Fill it out with compressed air in the morning between the hour of 8 and 10, which the energy is very expensive. You don't need to turn on your compressors anymore. You'll have high pressure air in the tank. There is a cost of the tank. There is a cost of maintaining the tank. What you